And we next have Rana Khoury. I hope I'm speaking it correctly. She's a postdoctoral researcher at Holy Spirit University of Kaslik, Lebanon. She works in the lab of Dr. Sandy Rihanna, and she will be talking to us about AR special text for AD diagnosis. Over to you, Rana.
Hello, everyone. Okay. So I wanted to ask Alex before, but I didn't have time. If the task maybe could be possibly done in AR, and this is the point of my talk is to present a pipeline to do augmented reality tasks for spatial cognitive tasks for Alzheimer's disease. So, for example, the spread of amyloid plaque and neurofibrillary tangles in Alzheimer, which are the two proteins that are thought to be correlated with the spread, with the progression of the disease. And the amyloid plaque first starts in the prefrontal cortex and then progresses and then spreads into the brain. And the neurofibrillary tangles start in the transinternal or internal cortex and then spread to the hippocampus formation. But the neurofibrillary tangles are thought to be much more specific to Alzheimer's disease, while the amyloid plaque spread is overlapped with normal aging in the early stages or with frontotemporal dementia. So it's good to focus on the neurofibrillary tangles, I think. And it's very important to be able to detect the disease in the early stages because it doesn't have symptoms in the preliminary part of the disease. There are no symptoms, so it's hard to detect it with MRI or PET scans. And so there's a need to create new tests to detect the disease, new cognitive tests, because they're low cost and easy. So, for example, this is a memory test that showed to be much more specific and sensitive to Alzheimer's disease, where they collected 20 years prior to death for more than 6,000 healthy individuals, and they tested multiple cognitive functions like memory, processing speed, fluid intelligence, and crystallized intelligence. And this spatial test showed to be the most specific and sensitive to Alzheimer's. Lately, to make the tests more realistic, they start to do these tests in VR and AR. And so they can create an entirely controlled environment where the patient can navigate and they can collect all sorts of metrics like the path he followed, the time he took to perform several tasks, and design any experiment they want. So it's much more flexible, and also they can translate a lot of the studies done on spatial tests for animals to these VR tests. So at first we thought of making an AR test, a specific AR test, but then we thought, why not make a pipeline so anyone can design any test they would like in AR. To scale it up even more, why not do it on a smartphone device with a headset, so everyone can use it at home, and then they can remotely assess the test that the patient can do at home. So the features that can be implemented in an AR is first the tracking of the device, the smartphone, how the device is moving in space, and so they can collect how the patient is moving. They can also track hands, so it could be more interactive and much more intuitive to pick up objects and move objects and interact with the 3D environment with his hands. Object detection if needed, and spatial recognition, where they can make the test can be performed according to the spatial environment of the user. So it can be more specific to his environment. Okay, so to do this, we first did the video is not working, I think. I don't know why. We first did the AR tracking in WebXR, And to do that, we use the WebXR device API, which can collect information from the inertial measurement unit of the smartphone. It can take information about the acceleration from the accelerometers and information about the rotation from the gyroscopes. It can combine it with features coming from the camera feed to correct for the device position, and at last it can copy this position to the virtual environment so that the virtual camera can follow the movement of the space. But I don't know why the video is not working. Sorry. Okay, can you see it now? Okay, so it can be inline in the camera, but it's more useful to make it like the left video, the right video, sorry, where we use a headset, a cardboard headset, and split the screen so that the virtual environment can be seen in with stereoscopic vision, as if it's in the environment. To do the hand tracking, we use the media pipe library. So first, the camera feed detects the hand, and then once it's detected, it's cropped, and then the landmarks of the hand are detected using a neural network, an SSD architecture with a mobile net feature extractor model, which is very convenient for resource-constrained environments like the web and the mobile, because it's fast. And then we try to do marker detection and pose estimation, where when the camera detects a marker, it should try to estimate the pose of the object. So we should know how exactly the marker is away from the camera. And to do that, we need camera intrinsics, like the field of view of the camera and the model coordinates and image coordinates of the marker. So here's where we face the biggest challenge, is that each one worked with us on its own, but when combined, there were too many computations being done both on the browser and the phone. And so the application lagged a lot. And now what we will try to do before combining it with the spatial recognition is to try to move some of the computations to the server side with a backend and do parallel processing with Node.js. What we can also try to do is with WebAssembly, try to code some algorithm in C++, for example, which is much faster than JavaScript, compile them to bytecode and make them run on JavaScript. And we can also use a web worker, but I think this will be the least useful for us. Finally, if we were able to do this and speed up the application, we will have a flexible application where users can choose which features to include. Like, it will be easy to design. They can choose between a set of features, and it will have a bigger impact. They can make it work on a browser, so nobody will need to download anything, and they can make patients test it and before they have any symptoms of Alzheimer's disease, and see if they can get anything meaningful from the test that they have designed. Finally, I would like to thank my supervisor, Dr. Sandir Hana, and I would love to have some input especially from neuroscience perspective, to see if there's anything meaningful that we can add to the application. Thank you.
Thank you so much, Rana. Any questions from the panelists or the audience?
Well, I can answer Rana's question. So I just wanted to say that absolutely we could do the kind of stuff that with augmented reality. I mean, it's kind of a dream to be able to do that kind of thing, like, because obviously we're looking at conditions that happen in the real world, and then you're giving people dots and on screens to look at. So doing something like that and assessing peripheral reaching and spatial ability would be incredibly cool. So yeah, that's just to answer your question. But I have no further questions about your talk. I thought it was really good though. Thanks.
Thank you. Yeah, I immediately thought that I didn't think of this kind of application before, and I immediately thought, okay, this would be even better than the things I thought of doing.
Yeah, it would be very cool.
Cool. Thank you so much, Rana. Any questions from the audience? It was very interesting uh, to hear about the application of AR in AD. That is really very interesting. Uh, any further questions do we have?
Yeah, I've just got an add-on question, I guess. It's just like, how do you think patients will respond to it? Like, have you been able to sort of, as like tests, because you know they struggle with dealing with certain tasks, and an AR environment might not be that comfortable for them and stuff. Like, do you have an idea of how they can cope?
So first, AR there's no problems in AR like VR, so they won't feel any dizziness because they will still see the environment, and they can still focus on things that are really in the space and not on a closed screen. And yes, this is why I'm trying to make it as much intuitive as possible by using their hands, because I realize not all senior patients will be familiar with AR games in general, and and the controls for them.
Thanks.
Okay, great. Really great. So we had a very